Welcome you all. Today we are going to see a topic on energy storage. Before that, my name is Dr. B. Sivasankari, Assistant Professor of Physics, SFR College for Women, Sivasankari. So this is the world net electricity consumption. The data we have collected from 2002 to 2025. So before going to see what is energy storage, we should know what are the importance of these energy storage systems. And the importance, if you see, means the thrust for renewable energy sources, variable outputs, energy buffering, importance in the present context. Then we should know why new technologies and devices are needed for these energy storage systems. To answer this, we are having the types of energy storage system. ESS means energy systems. The first type is mechanical energy storage, the next is magnetic energy storage, third is thermal energy storage, then fourth is chemical energy storage. First we are going to see mechanical energy storage with the help of an example of flywheels. The principle used in flywheel is energy stored in the form of mechanical energy. Lightweight fiber composite materials are used to increase efficiency. The energy density is calculated using the formula 0.05 mg by kg. Here the efficiency neta equal to 0.8. Here the flywheels use the formula E by m equal to half v square equal to sigma by rho, where v is the circular velocity of the flywheel, sigma is the specific strength of a material, rho is the density of the material. Then properties of some materials used for building these flywheels, if you see, means steel, aluminum alloy, titanium, glass fiber, reinforced polymer, carbon fiber, reinforced polymer. Then the advantages and disadvantages of these flywheels, if you see, means very compact when compared to other energy storage systems. Flywheels are used for starting and braking locomotives. A flywheel is preferred due to lightweight and high energy capacity. It is not economical as it had a limited amount of charge and discharge cycle. Then next is compressed air energy storage. The operation, if you see here, means in the diagram or in general we can say the operation as uses of peak electricity to compress air and store it in airtight underground caverns. When the air is released from storage, it expands through a combustion turbine to create electricity. Then electrical energy density is calculated using 0.4 mg by kilogram. Here the neta efficiency is 0.5. Then what are the advantages and disadvantages of these compressed energy air storage? If you see, means fast draw backup, geological structure and reliance. The next is pumped hydroelectric energy storage. The operation, if you see, means it consists of two large reservoirs located at different elevations. During peak demand, water is released from the upper reservoir. If production exceeds demand, water is pumped up and stored in the upper reservoir. Pump used is a combined motor and dynamo. Most effective with large capacity of electricity over 2000 megawatt. Then the advantage, if you see, means the energy density is 0.001 and the neta efficiency is 0.8. Then the here disadvantages, it is a geographical dependence. Then the capital cost is massive. Then it can be affected by soil erosion, land inundation and slitting of dams. The next is magnetic energy storage superconductors. This we say it as SMES systems. Store energy in a magnetic field created by the flow of dielectric current in a coil of superconducting material that has been cryogenically cooled. The principle used here is at low temperatures, electric currents encounter almost no resistance. They store energy in the magnetic field. They are environmental friendly and highly efficient. Depending on the peak field and ratio of the coil's height and diameter capacity of storage, for this type it will vary. Then next is electrochemical storage. So what is this electrochemical storage? Before saying that, you should know what are the types of batteries. The batteries we say means based on the capacity we can say small capacities batteries. Then lead acid batteries. What is lead acid batteries means? They use a chemical reaction to do work on charge and produce a voltage between their output terminals. The energy density is 0.6. Efficiency is 15% and they are produced in large scale. The next is you should know in energy storage you should know it is what are supercapacitors. Their role in energy storage is a massive one. Why we are using use of thin film polymers for the dielectric layer? We are using mainly because for thin film polymers for the dielectric layers. Then carbon nanotubes and polymers are practical for supercapacitors. In future, carbon nanotubes with ceramics are used as supercapacitors. They if you see means they reduce the effect of fluctuations, then longer lifetime which reduce maintenance cost. This is the reason for mainly using supercapacitors. The next is lead acid battery. So this is the diagram of lead acid battery. Then underground thermal energy storage. What are the methods and what are the uses? If you see means using methods of heat exchange, it is working on the principle of heat exchange. Here we can say it as two types: aquifer thermal storage, duct thermal storage. Aquifer thermal storage means usage of underground water. Duct thermal storage means usage of plastic tubes. Their environmental impact, example, de-ice frozen roads. Then applications of thermal energy storage: air conditioning. A salt hydrate acts as a whole cool heat sink for the air conditioner working fluid. The stored heat is rejected from the salt hydrate during night to heat the surrounding air. The energy density is 0.25 and the efficiency is 0.8. Example, sodium sulfate decahydrate. Conclusion: if you see means a reliable and affordable energy storage is a prerequisite for using renewable energy. Energy storage therefore has a pivotal role in the future. Energy storage is the most promising technology currently available to meet the ever increasing demand for energy. Thank you.